First of all, I want to thank very much to the organization, to the association, for the invitation to be here, and at the same time to say you that Mumbai was the city that warmly hosted my 23-year-old daughter during 1 year. She loves this country, she loves this city, and so do I. So, going inside my presentation, the topics are a little presentation of my organization and my group of organizations, and then I will enter the subject around fibers for sensing applications, fibers for energetic applications, and printed sensors on textiles. CITEV group, as you know, in Europe, normally countries developed, founded organizations to operate between universities and companies in order to transfer technology. That's the case in Portugal. Portugal is a very, very small country in Europe, but the textile and clothing sectors are very, very important for us. 10% of the total employees in industry are related to textiles and clothing industries. So this is very important for us. We are only 10 million inhabitants in Portugal, but the business around textiles and clothing is about 8 billion euros. So CITEV is the technological center for textiles and clothing industries, and 13 years ago, the technological center decided to create a new center focused on nanotechnologies and smart materials. Why? Because at that time, we realized that materials will be the future of textiles, mainly in a country where the minimum possible labor cost per month is around 900 euros. So we decided to create this center, and now this center is a reality, as I will show you. At the same time, we decided also to establish collaboration with other countries. That's the case in India. We decided to have a contact point here, exactly in Mumbai. I will talk about that in a few periods of time. So these are our premises in the north of Portugal. And your contacts in Mumbai are Mr. Jacob Kati, is there, and also Mrs. Arpana Cha, as contact points with our staff. Of course, we have several services available also for Indian companies. So inside the technological center, we have testing services. All you can need, of course, we are able to make available for you. We have several laboratories in several areas, and of course with the required accreditations. So another big activity in our center is product and process certification, several kind of certifications. I know lots of Indian companies are now trying to enter the protective equipment market. We are able to make the certification for CE mark, for instance, or all the labels inside the Ocotex certification. Okay, finally, research and development and transfer of technology, consultancy, and so on. Some other activities. So, enter in CENTI. CENTI is the spin-off related to nanotechnologies, advanced materials, and this is a joint venture joining the Technological Center for Textiles and Clothing Industries with 3 universities, the 3 main universities in the north of Portugal, and 2 technological centers, one for the leather industry and finally the Center for Automotive and Aeronautical Industry in Portugal. So CENTI is focused in put nanotechnology and advanced materials in textile sector. 3 main competencies: functional materials. Second one, smart materials and modeling, design, and engineering. And we address our technology, first of all, to three main areas: automotive and aeronautic industries, architecture and construction, and finally, sports, health, protection, and well-being. Three steps philosophy. We work for industry. We don't make research only for publishing papers. So our activity is completely focused on companies. Otherwise, we don't have money to live, because we live from the sales we do near our companies and companies around the world. So for this reason, we make research, but we prototype our research to show to the companies, technicians, entrepreneurs, that this works. This is very important. Prototyping is very important. And then we help companies to adopt the technology, and in certain cases, we participate in the first series, in the first prototypes to make the market proof. We work not only with the traditional materials, we have expertise in other materials. Why? Because we are joining traditional textiles with cork, with ceramics, with other kinds of materials to obtain new products. 65 researchers in that group, and during the last year, we applied for 20 patents. I think that's a very good figure for our center. Here you have the patents we claimed for. The most part of those patents are not owned by the center. The owners are companies. So we work for companies, and companies are owners of the patents. In some cases, we have ownership with companies. Competencies. First of all, nanoparticles. We have a very strong capacity developing and producing nanoparticles. Not only at laboratory scale, but as you can see, we have the equipment to prototype till 650 liters in order to produce the sufficient amount of material to be used in industry. Second one, new fibers. We have the only plant in Europe to produce 3-component fibers. This technology allows us to produce fibers with 3 different polymers inside. I will return this point. Third competence related to surface functionalization. And we developed a technique using ultrasound spraying in order to obtain very, very thin, at nanoscale, layers to functionalize without affecting the natural characteristics of the textiles. Printed electronics. I mean, we put electronics inside textiles by printing processes. Very, very similar to traditional printing process in textiles. Printed light, for instance, for protective equipment or curtains and so on, we are using the deposition of certain materials in order to transform textiles in lamps. And finally, we have a small group working in the hybrid systems. I mean, to put the textiles in contact with computers, let's say. Facilities and equipment are related to those technologies. Of course, polymer compounding, non-conventional fibers, non-conventional fibers twisting technology. And we detected the opportunity from sensors in textiles to textiles as sensors. How to do that? First of all, fibers for sensing applications. The opportunities in niche markets with very high value added normally requires some kind of sensing or actuation. This is an example, only an example. This is a medical textile, a medical device, and we need to put inside several kinds of sensors. In the past, those sensors were integrated, glued, sewed to the textiles. But we developed a technology to produce fibers as sensors. Fiber-based strain sensors for several applications: detection of mechanical failure or health monitoring, functional wearable fibers for clothing and non-clothing applications use the scalable three-component melt spinning process. So these are examples we developed, for instance, to detect the volume of arms in case of surgery and so on. So we used fibers exactly to identify, to measure the difference, the delta of volume of the arms. The strategy was very simple. We used piezo-resistive strain sensor fibers with a cross-section configuration of side by side. It means we used two polymers, but in three different parts. The first part is a thermoplastic elastomer, and inside we put a carbon-based conductive compound. So those fibers have simultaneously the capacity to be processed in traditional textile processes, and also to be conductive and measure the mechanical differences. This is a scheme of the process. Basically, we have three extruders sending the three different materials inside the fiber. This is the result, and we measured the result, and at the end of the day, we realized that those fibers are perfect to this function. So the results: the filament shows a clear electrical signal during elongation, higher amplitude of response for higher draw ratios. The higher the draw ratio, the higher the hysteresis observed in first cycles, and both produced fibers are able to be integrated on textile structures as fully integrated sensors. Good results. But I will show you some other results: other sensor fibers, energy harvest fibers, and energy storage fibers. First example for temperature measurement: nanostructured polymer-based conductive fibers, three-component fibers, multi-filament yarns for textiles using conductive polymeric compounds. Second example, magnetic fibers. As you know, nowadays the production of magnetic fibers for magnetic fabrics are widely used, for instance, in iPhones or other kind of devices. So the challenge was how to produce that. We decided to produce magnetic fibers inserting nanoparticles, magnetic nanoparticles in the polymer. Another example, piezoelectric fibers. As you know, a piezoelectric cell is nothing more than the combination of three different polymers. So what we tried and reached a result to do was to put these three components in a fiber. What you see is exactly a fiber as a piezoelectric cell. At the end of the day, we are able to produce electricity pressing a textile structure. We are using now these structures in the streets, in the roads, to produce electricity to lights, traffic lights. And finally, a big challenge: to produce fibers and covered fibers to become super capacitors. So we construct batteries in the shape of a fiber. Not a fiber, a filament, because it is impossible to use small diameters for this. So the prototype is running now, and it was possible to mix photovoltaic fibers with supercapacitor fibers in order to have a structure, for instance, for architecture purposes, in order to collect the energy from sun and store the energy as electricity. So some words about printed sensors. This is a completely different strategy because we start with the traditional structure, and then we use printing processes with special pastes, with very special materials to become a sensor. So here you have 4 types of sensors printed, fully printed: a capacitive sensor, a biosensor, a printed capacitive sensor integrated with LEDs, and finally a printed flexible sensor and actuator on textiles. Now you can see some products. The first one is a heating band. This is a band to heat car seats. The idea and the practice. Nowadays, BMW adopt this technology, so it is possible to produce all the electronic sensor of presence and to heat the seat when the textile is in a plain formula. So after that, we can make the confection of the seat, and all the electronics are inside the textile. This is a real case. The second one is a printed and integrated light device in curtains. The idea was to have a curtain with light emission elements, and the on-off device is exactly a sensor. You can see in the lower left part our work in order to have stretchable electronic circuits, because textile is flexible and is stretchable, so it is necessary, or I mean compulsory, to have as well stretchable circuitry to be able to be integrated in textiles. And finally, you have a textile, a very thin textile, polypropylene, I think, with a circuit printed on. So one of the cases is exactly the A-pillar of a car. This is a Peugeot car, where we integrated in the pillar a sensor and light emission elements directly in the textile, and then this textile is used for polymer injection, in a traditional polymer or plastic injection. This product received an award last year. So ongoing developments. The next step is to create more electronic devices as fibers. And now a very special group of research centers and companies are involved in a huge project in order to develop what you see in the left part of the slide. We will develop fibers as electrodes, as transistors, as LEDs, as energy-related fibers and sensors. The idea is exactly to construct new families of textiles for home, to integrate the functions, the communication interaction between people and the house. So thank you again. Thank you for the invitation. Thank you for the attention.